In this video, we'll go deep into lumber sizing, including why a 2x4 is not what you think it is, how nominal sizes mislead beginners, and how professionals choose depth, width, and length to avoid long-term problems that don't show up on inspection day. In next video, you'll see exactly how solid wood is used differently in single-family homes, multifamily buildings, light commercial projects, decks, and accessory structures, and why the same piece of lumber can be perfect in one building and completely wrong in another. Let's start at the foundation, with lumber sizing. The size printed on a piece of lumber is not its actual physical size. A 2x4 is not a measurement. It is a name, and confusing the two causes real problems in real buildings. Historically, a 2x4 referred to the rough sawn size of the board immediately after milling. At that stage, it was close to 2 inches by 4 inches. But as lumber began to be planed smooth for consistency, handling, and safety, material was removed from all sides. The name stayed. The dimensions changed. Today, a standard 2x4 measures approximately 1.5 inches by 3.5 inches. That difference is not trivia. It directly affects structural capacity, wall thickness, insulation depth, finish alignment, and connection detailing. Beginners tend to think in nominal sizes because that's what the store labels show. Professionals think in actual dimensions because that's what the building experiences. When calculations, layouts, or details are based on names instead of measurements, small errors stack up quickly. This misunderstanding shows up everywhere. Walls that don't align with foundations, insulation that doesn't fit properly, finish materials that come up short, connections that don't seat the way they were drawn. None of those failures feel dramatic at first. They simply create friction at every stage of construction. Once you understand that lumber sizes are historical labels, not physical truths, the next step is learning how those labeled sizes are actually used in practice. That starts with the smallest category of framing lumber, the 1x system. 1x lumber refers to boards labeled as 1x4, 1x6, 1x8, and so on. Despite the name, the actual thickness of 1x lumber is approximately 3/4 of an inch. That thin profile is the key to understanding where it belongs and where it doesn't. Professionals use 1x lumber for tasks that do not involve carrying structural load. It appears in furring, trim backing, non-structural blocking, temporary bracing, and as a substrate for finishes. In these roles, its thinness is an advantage. It's easy to fasten, easy to adjust, and easy to remove or modify later. What professionals do not do is use 1x lumber as a load-bearing structural member. It does not have the thickness, stiffness, or stability to reliably carry framing loads. If you see 1x lumber supporting weight in a wall, floor, or roof, something is already wrong. The danger with 1x lumber is not that it fails dramatically. It's that it deflects, creeps, and moves just enough to cause long-term problems. Doors go out of alignment. Finishes crack. Fasteners loosen. None of this looks like a structural collapse, but it creates buildings that feel cheap and unstable. Professionals understand that 1x lumber plays a supporting role, not a structural one. They treat it as a helper material, not a backbone. Once that boundary is clear, construction shifts into the category that actually carries buildings, the 2x system. 2x lumber is the structural workhorse of light frame construction. This is the category that carries walls, floors, and roofs, and where most structural decisions actually live. Despite the variety of labels, all 2x lumber shares the same actual thickness of approximately 1.5 inches. What changes is the depth. That depth is not cosmetic. It controls stiffness, span capability, and how a structure feels once people start living in it. 2x4s are commonly used for interior non-load-bearing walls, short spans, and partitions. They also appear in older construction standards where insulation requirements and performance expectations were lower. While 2x4s are not weak, they offer limited insulation depth, reduced stiffness in exterior walls, and less tolerance for moisture-related movement over time. 2x6s have become the standard for modern exterior walls and many interior load-bearing walls. Professionals choose 2x6 framing not because it sounds stronger, but because it performs better over the life of the building. The increased depth improves wall stiffness, accommodates modern insulation requirements, and reduces drywall cracking as the structure dries and settles into equilibrium. As members get deeper, 2x8, 2x10, and 2x12 lumber enters floor and roof systems. These sizes are used for joists, rafters, ceiling framing, and beams when doubled or tripled. In these applications, depth matters far more than width. A deeper member resists bending dramatically better than a wider one. This is why engineers almost always increase depth before increasing width. Stiffness grows exponentially with depth, while width offers diminishing returns. When floors feel bouncy or roofs feel flexible, the issue is almost always insufficient depth, not insufficient strength. Understanding this principle explains most professional sizing decisions. The goal is not to meet minimum code. The goal is to control deflection, vibration, and long-term movement so the building feels solid years after it's occupied. But size alone isn't the whole story. Length availability also drives design in ways many people never consider. Lumber is not available in every length you can imagine, and professionals never assume it is. Real construction is designed around what can be sourced reliably, not around idealized spans on paper. Common framing lumber lengths are 8, 10, 12, 14, and 16 feet. Longer lengths exist, but they are less common, more expensive, and often treated as specialty material. 18 and 20-foot members typically carry premiums and availability limitations that affect both schedule and budget. Professionals design framing systems to work within these length constraints. They align wall layouts, floor spans, and roof geometry so members can be installed in single continuous pieces whenever possible. This reduces labor, minimizes waste, and limits the number of joints where movement can occur. Excessive splicing introduces problems. Every joint adds labor. Every splice creates a potential movement point. Every unnecessary connection increases inspection scrutiny and long-term risk. Professionals avoid these outcomes by designing with standard lengths in mind from the start. This mindset also influences beam design. Instead of forcing long single members, professionals often use doubled or tripled dimensional lumber that can be sourced consistently and installed efficiently. The result is a structure that performs well without relying on rare or expensive materials. Once length is understood, the conversation naturally shifts to vertical members, especially posts. This is where one of the most common framing mistakes shows up. Posts look simple. They stand there. They hold things up. And because of that simplicity, they're one of the most commonly misunderstood structural elements in light frame construction. 4x4 posts are widely available and heavily marketed for structural use, especially in retail environments. That availability creates the illusion that they are a reliable default choice. In reality, professionals avoid 4x4s for most structural applications whenever they can. The problem is not immediate strength. The problem is long-term behavior. 4x4 posts are prone to twisting as they dry. Their smaller cross-section means moisture leaves unevenly, and once twisting begins, it cannot be corrected in place. They also offer limited load capacity and perform poorly over time in moisture-exposed environments like decks, porches, and exterior structures. Professionals know that a post doesn't just carry vertical load. It must remain straight, stable, and predictable as the building dries, seasons change, and loads shift. 4x4s struggle to do that consistently. That's why 6x6 posts are the professional standard. 6x6 members provide greater mass, which reduces twisting. They distribute load more evenly and tolerate moisture cycling far better over time. Surface checking still occurs, but it is less structurally significant because the remaining cross-section is substantial. When professionals choose 6x6 posts, they are not overbuilding. They are choosing stability over minimum compliance. The difference shows up years later, when structures framed with larger posts remain aligned while others begin to creep, twist, and complain. This same philosophy carries through all professional sizing decisions. Builders are not asking what is the smallest piece that works. They are asking what size will behave well for decades. And that mindset becomes even more important when we look at how lumber sizing changes by building type. Thanks for watching. If this was helpful, like the video and subscribe. More practical construction knowledge is coming very soon.